Okay, guys, this is the second part for the binomial model. And in this part, what I'm going to talk about is RNP, which is risk-neutral probabilities. And the risk-neutral probabilities, okay, are actually coming from the following observations. What you want to do now is when you go up and when you go down, let's say you have 100 here, and you have 200 here, and 50. You want to actually evaluate the probabilities, okay, which are imposed by this model of going up or going down. So you do not want to have your own probabilities. You do not want to have subjective probabilities. You don't want to have subjective probabilities. So basically probabilities that you yourself as an analyst assign going up or going down, but you want to have a probabilities which are coming from the model itself. Okay? And once again, the thought is that those probabilities have to somehow reflect the current state of affairs. Okay? That's why they are called risk-neutral probabilities, because they actually refer to the current state of affairs. Now, the link between the replicating portfolio and risk-neutral probabilities is what we call through Arrow-Debreu securities. The idea is that if you have basically the following security, you have 100 here, and then here you have 200, and in this case, the security will pay $1, and in this case, it will pay $0. Okay? So this is like a bond, which basically says, okay, you don't know whether it's going to be 250. But if it's going to be 200, I'm going to give you $1. And if it's going to be 50, I'm going to give you $0. Okay? So it's an option, but it's a funny option, which pays you $1. Now, if you have, and the other Arrow-Debreu securities is 100, 200 here, 50 here, and it will pay you $1 here and $0 here. Okay? So this is called Arrow-Debreu securities. And the basic premise of this thing is that the price of this security will exactly be the probability of going up or the probability of going down. Why is that? Think about the usual coin throw, right? So let's say that I have a coin throw with head tails. Okay, and I want to find out what is the probability, okay, of getting half or zero, right? I want to find out whether this is a fair coin or not. So how do you do that? What you want to do, you want to say the following, okay? So if I'm throwing the coin a lot of times, what is going to be my outcome? Okay, so let's say that my probability of getting 1 is p, and my probability of getting 0 is 1 minus p. So their expected value is p times 0 plus 1 minus p times 1 plus 1 minus p times 0 is going to be p. Okay? So what you're saying is that if you throw the coin enough times, and the probability of getting head is it's not a fair coin, it's a fake coin. Okay? So it's 1/3 for the head and 2/3 for the tail. So so you will lose or you will win 2/3 of the time. If you throw it enough times, you will be able to observe this pattern. Okay? So that's the idea behind this. Okay? And you can see that the expected value is p. So it's exactly the same case here. Okay? You can think about this as being a binomial, as being like a coin throw. If you get 200, you will get a 0, and if you get 1, you're getting actually $1. If you get 50, you're getting $1. Okay? And then the probabilities, the value of this guy, it will be like this. It will be p. Okay? So in this case, it will be exactly the probability of going down, and in this case, it's going to be exactly the probability of going up. So when you do a replicate, so you can value this by replicating portfolio, and because you can value this by replicating portfolio, you can actually find those probabilities. Okay? So the economical reasoning behind this kind of models is that I can actually represent, through replicating portfolios, the cash flows of something like that. Now, if I have those securities, I can price anything, okay? Let's say that the price of this security is going to be, I don't know, let's say Debreu 1, okay? And the price of this security is going to be the bro 2, okay? And now, let's say you want to value a call option, okay? How do you do that? Well, it's actually very easy, because let's say that your call option with a strike of 100, so you have 100 here and you have 0 here. And then it is clear how to replicate, how to create your, how to price it, right? Because if you know that the price of this guy is D1 and the price of this guy is D2, you will just say, okay, I have D1 times 100, because I have 100 units of this guy, of this guy, plus D2 times 0. Okay? So in this case, it is actually going to be very, very straightforward to value this. And you can think, and this is interesting, because you can think about call and put options in some sense replicating those kind of things. Because here you are getting 100, but if you divide by 100, okay, let's say you value this option. If you divide by 100, you will get exactly this kind of instrument, 1 here and 0 here. And if you have a put option, okay, you have 0 here and 1 here, and you value this put option, so you're going to get here 50 and here 0. You divide by 50, you will get exactly this security. Okay? So in this sense, the Arrow-Debreu securities, okay, and the Arrow-Debreu probabilities, which we call risk-neutral probabilities, sometimes you will see Arrow-Debreu probabilities in the literature, okay, are actually have the linking to the replicating portfolio methodology, because you can think about probability of being up, of going up or down, as a price of securities, which pay you $1 in each state and 0 in each other state, okay? And for this observation, by the way, it looks trivial observation, but these guys actually got a Nobel Prize of Economics, or one of them, I don't remember. Whoever watches this video, and I'm not making justice to the people, I do apologize. I don't know all this history too well. I just know that one of them or two of these guys got the Nobel Prize in economics, partially because of this kind of observation. Okay? So now, how do we value something like that? Well, it's actually easy peasy. What you want to do now, okay, you can actually say that here, one way to do it through replicating portfolio. Another way to do it is to say, okay, what is the expected value of my guy in the future? The expected value of my guy in the future, okay, is going to be the probability of going up times 200 plus the probability of going down times 50. And the expected my guy in the future is my futures price of the stock, my futures price of the stock, okay? And the futures price of the stock, because you don't have interest rates, is just 100. That's all. That's all there is to it, okay? So when you have something like that, now PD and PU actually have connection, because PU times 200 plus 1 minus PD, PU times 50 equals 100, okay? So in this case, what are you getting? You're getting here that you are getting that PU times 200 plus 50 plus minus 50 times PU equals to 100. And here what you are getting, that 150 times PU times going up equals to 100 plus 50 equals to 100. So it means, okay, that PU going to be third and PD is 1 minus PU. So you can either go up or down, right? The sum of the probabilities must be 1 is equals to 2/3. Once again, those probabilities have nothing to do with your subjective probabilities. You can maybe say that for sure you know that 100 going to 200. It doesn't matter at all. Your personal feelings, your subjective probabilities will never, ever, ever matter in the way, in sense of pricing. Whatever matters is whatever the model says. And the model is actually designed to actually find the option price based on your data today. Okay? Now, of course, there are many things that we need to consider. I'm going to consider them very soon. Okay? Now, how do you value the option using those probabilities? So, for example, if you look on the call option, you're going to get here that it's 1/3 times 100, because you have 100 units here, plus 2/3 times 0. So you're getting that your call option is 100/3, exactly as a price as we got using replicating portfolio less time, right? And it's not surprising, because you will have two methods a priori. They're not the same. You want to get the same price. But in reality, they are the same because of this 1, 0 and 0, 1 game. Well, okay? Now, why is it convenient? This is convenient because now you can actually create your own tree like this. Blah, 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 going all the way, right? So it's going to be 100 here, then 200, then 50, then 100, then here it's 400, then here it's going to be probably 200, etc., etc. And then what you want to do, you want to discount back, okay? So let's say now that you are actually terminating the option here, 425. Exactly the same option, but you have 100 and 0. So how do you value such an option, assuming no interest rate, okay? So you know that probability of going up is 1/3 and probability of going down is 2/3, okay? So how would you do this option? So you will just discount back. So in this case, for example, what will be the price of the option at this node? Is it's going to be 400 times 1/3 plus, and here, okay, and here, by the way, because it's 200, okay, because it's 200, you are actually, no, it's not 400, sorry, it's 300, right? Because here you're getting 4 minus 100, so it's 300. Your payoff here is 300. Here is 100, and here is going to be, let's say, 25. So here, your payoff is going to be 300. Here is going to be 0, and here it is going to be 0. Okay, so it's 300 times 1/3 plus, and now you're having 200 times 2/3. Okay, so whatever you get here, this is your price at this node, okay? Or, yeah, this is your price at this node, for example. All right? So, and then you discount back once again. Okay? So in this case, it's going to be done recursively. So you know your price here. You know your price here, and you know your probabilities going back. You're basically going discount by these probabilities. Now, what happens if you have interest rates? The only thing that happens if you have interest rates, okay, is that you are going to, so first of all, the calculation of the probability is going to change a little bit. So now, in general, okay, what you are going to get, let's say that you have your stock, which is S here, and then your future price is ES to the RT, okay, and then you say, let's say you have up and down. So then the equation is going to be like this. It's S times going up plus times PU plus S times going down times PD equals to S to the E to the power of RT. Why is it RT? Because it's RT, because what you want to do, you want to include interest rates. And the future price, if you have interest rates, is exactly this. Okay? So now, you cancel the S's, and once again you're using here that 1 minus PU, so you're going to get here U PU plus minus D PD, okay, plus D equals to E to the RT, and from that you get that PU, let's say, equals to E to the RT minus D divided by U minus D. Okay? So you found the probability of going up, you found the probability of going down, and when you discount back, you just need to include the interest rate. So the formula of going, let's say you have here a price of the option OU, option up, and here option down. The formula here, the formula for this guy, is going to be basically PU times option U plus 1 minus P U or PD times option D, and then you want to discount back E to the minus RT. Now, what is this RT? RT is this step here. So if this is 1 month, and let's say you have a maturity of 3 years, it's going to be a 36 step tree. If it's going to have a 1 year maturity and you have 1 month, it's going to be a 12 step tree. Okay? So then you're going to basically discount back until you reach the beginning. Okay? Once again, all right? Probably here I have 100 here. Apologize, because when you go down, it's around 100 or something. Okay, but I hope that the principle is clear. I mean, you create this tree like this, and then you start discounting back. the one thing that you want to remember, okay, that you can actually, you can actually value other cash flows like this, right? You can actually think about this, for example, valuing bonds. So for example, let's say that you have the following. You have 100 here, and then you go to 200, and then you go to 50, and now you go to 100 here, and here you go to 400, and here you go to 25. And now what you want to do, you want to say yourself, okay, what will happen here if I'm going to value a bond, a zero coupon bond with 100 principal? So in this case, I'm going to have 100. Because the company here, this guy is intact, it can actually return the debt. Here I'm going to have 100. It's on the border, but it's still okay. But here I'm going to have a 25. Okay, so when you are actually discounting back, and now the probabilities do not change, so you can use the same probabilities. So in this case, for example, the price of this bond is going to be the following. It's going to be 2/3 times 25 plus 100 times 1/3 in this case. Here, okay, it's going to be 100 times 2/3 plus here 400 times plus 100, plus 100, right? Plus 100, because the principal here is 100 times 1/3. So in this case, and now let's assume that we don't have an interest rate for now. If you have an interest rate, you just discount by e to the minus RT, whatever, right? So you don't have an interest rate. So here you are going to have a 200 bond, and here you are going to have basically, 2/3 times 25 plus 100 plus third. So it's 50 divided by 3 plus 100 divided by 3. So it's 150 divided by 3. So here you are going to have 50, and then you discount back, and you will get the price here. Okay? So once again, you can use this, you can utilize this in order to value the corporate liabilities. Okay? And so that's basically the principle behind it. Now, there is something called American options. What you want to do, but I don't want to talk about this too much, but if you have an American option, you have like an early exercise option. What you want to do, you want to have early exercise, so you compare your payoff here with the price of the option coming back. And if the price, and if the early exercise is more, let's say you exercise here and your payoff here will be 50, when you come back it's 40, so you will exercise. But if your payoff is 50 here, but if you come back like this, it's going to be 60, you won't exercise, right? Because it's better to sell the option than to exercise it. Okay? So this is going to create something like early exercise boundary. I do not want to talk about this because it's going to take us too much into option history, option valuation, which I don't want to tackle now. Okay? So it's actually a very straightforward and convenient method, okay, to value options, because you create these three ones, and then whatever your payoff here, you can just discount by 1/3 and 2/3, okay? When you do a replicating portfolio, on the face of it, you need to do the replicating portfolio at every point. So it's going to be very, very cumbersome. But if you use these probabilities, it's actually going to be very smooth, okay? So that's the crux of it. That's basically the connection between risk-neutral probabilities, option valuation, and this model. Now, one thing, right, I never told you of how do we decide going up or down. How do we do it? So basically, here's the idea. What we assume a normal distribution for the returns. We assume a normal distribution for the returns, and this binomial model, what it does, it actually approximates the moments of this distribution. So it has only two things. It has only the expected value and sigma, which is your volatility, which actually measures how random it is. So the larger sigma is, the more random you are. So it turns out that in this case, in order to replicate this return distribution, what you want to do, you want to multiply by square root of t going up. So up, this is your up, and your down is actually going to be s to the minus sigma square root of t. Okay? So when you do this, and every time you multiply by this guy and by this guy, so for example, if your volatility is 0.2, okay, and let's say that t is going to be 1 month. Okay, so the volatility is given in annual terms, so then your up movement is going to be basically square root of 0.2 divided by 12, okay, And your down movement is going to be basically 1 divided by square root 0.2 divided by 12. Okay? So basically not this, but you need to multiply it by the exponential, right? So it's going to be basically e to the 0.2 divided by 12 square root and e to the minus 0.2 divided by 12 square root, okay? That's what is going to happen. So once again, don't forget the e, okay? But the down, the up and the down, the up times down has to be 1. That's the idea, okay? So if you know the up, you know the down, and what you multiply by sigma times square root of t. And of course, the question is how to find sigma. So the whole different kahuna. I actually talk about estimating sigma using all this Garch's model and all that. Usually what you do, you look on what we call implied vol or volatility surface, which gives you like a matrix for a strike and an expiration, which options, which volatility to use in order to create this tree, okay? So this is going to be, so this was a very short introduction to the options theory. I talked about the binomial model. I talk in other videos about Black-Scholes formula. I do not want to touch the Black-Scholes in this video, not to distract you, okay? So good luck on the test, and hopefully those videos that I had clarified for you the situation, all right? Thank you and have a great day. Bye.